All right, good morning, everybody. Today we're going to cover chapter 3, section 5. Division of whole numbers. We discussed so far addition, subtraction, multiplication. Now we only have one more left. That's the division process. For example, we know that addition leads to multiplication. That's what we did last section. 3 plus 3 plus 3 plus 3 is the same thing as 3. Since it happened 4 times, so it's times 4 equals 12. So that means, repeated addition equals multiplication, same ways that repeated subtraction leads to division. $18 divided by 6. So we know we have 18 objects and we have to put them in groups of 6. How many ways can we do that? So we have 1, let me use circles, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 6. This makes it 12, and this makes it 18. We have 3 groups. So 18 minus 6 is 12. 12 minus 6 is 6. 6 minus 6 is 0. So 1, 2, 3. So those are the inverses of each other. What's also pretty cool, and as much as I hate calculators, there's the way you would do this on calculator is, yeah, you could type in, let's say 135. If I asked you 135 divided by 15 is what? What you would do in a calculator, here's method 1. Type in 135, press minus, and type in 15, and count the number of times you press equal. What's going to happen, the first time you press the equal sign, it's going to take 135 minus 15, give you 120. You press it again, you get 105. Press it again, you get 90. Press it again, you get 75. Press it again, you get 50, 65, or 60, I mean. You press it again, you get 45. Press it again, you get 30. Press it again, you get 15. Press it again, you get 0. So count the number of times you press the equal sign. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's your answer. All right, so that's one way. Another way you could do it, using the commands on the calculator, the number, you see how many times is 15, and press the K button this time. So 15 minus the K button, and type in 135. And same thing. Count the number of times. Number of times 0 was pressed. And that's your answer. It's the same thing there. So I thought that was pretty cool. So what this shows us is subtraction, division are similar operations. They do the same thing. So we're looking here is, let's look at set, or what are called partition models. Remember what a set is. So if we had 18 cookies, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here's our set. So we're going to do 18 divided by 3. We have 18 cookies and we have 3 students. How many do they each get? So what we do is we have each student bring their box or their bag, and we start putting, this one gets 2, this one gets 2, and this one gets 2. They're still left over. So the next one, and the next one, and repeat this. This is going into sets. All the cookies are gone. Each student has 6 cookies. So that's how we look at sets. Right, that's the first one. So that's the partition model. So we take the original number of sets, we partition them in how many groups we want, and then the number of elements in there tells us how many we have. The next method, or the next model, I should say, is called the missing factor model. Remember, factor is, for example, if I had the number 12, what are all the possible factors? 1 times 12, 2 times 6, 3 times 4. Those are the factors of a number. So the missing factor model says this: for any whole number, numbers A and B, remember, whole numbers start with 0 and go on to infinity. So any whole numbers A and B. With B not being 0. If it's 0, it ruins the whole thing. So any numbers A and B with B not 0. So we know that A plus B equals C. No, not A divided by B equals C. If and only if, remember, from now on, whenever I say if and only if, I'm gonna write IFF. So with B not equals 0, A divided by B equals C, if and only if C is the number C. If only C is it has to be unique. That satisfies the equation B times C equals A. So let's show you what this means. This is a theorem, actually. So we have 2 numbers. A divided by B equals C. If and only if B times C equals A. all we did was multiply b to both sides. So we have a divided by b equals c. If I multiply both sides by b, those cancel. So that's what's really happening there. So that's how we test it. So that's the missing factor model. For any whole numbers a, b, and c, actually there should be a c in there, and c, with b not equal 0, a divided by b equals c, if and only if c is the unique whole number that satisfies the equation b times c equals a. That's what we're looking for. When we have these equations, the division equations, let's look at the terms used. We have a divided by b equals c. A is called the dividend. B is called the divisor, because tells me how many times I divide it. And C, this one's called the quotient. That's the answer. So the dividend is the top, the divisor is on the bottom. How many times does B go into A? And the quotient is the answer of that. Okay, we've noticed that we've used a couple of examples here of, we could do division like this. This is the same thing as A divided by B. The same thing as B goes into A. And the same thing as B divided by A. These are all mean the same thing. They all equal C. So these are the different ways of we can represent. Representation of division. That all of these symbols mean the same thing. A divided by B. All right, let's look at the properties. The properties of whole number division, or division by whole numbers. Here's the first note. The set of whole numbers is not closed under division. Remember, when we say closed, a condition is closed. If I had 3 plus 5, that equals 8. These are all whole numbers. Multiplication, 1 times 4 equals 4. These are all whole numbers. They're all unique. Subtraction isn't. These are closed. Not closed. Subtraction. 2 minus 5 equals -3. -3 is not a whole number, so it's not closed. Division. 4 divided by 5 is 0.8. 0.8 is not a whole number, so it's not closed. So that's what we're looking at. Here's the first one. Division algorithm. Remember, algorithm is simply an instruction sheet, a series of steps. So the algorithm says this. Given any whole number, A and B, where B does not equal 0, there exists a unique whole number, say C, called the quotient, and R, the remainder, such that, so given any whole numbers A and B, where B is not equal to 0, there exists a unique whole number C, called the quotient, and R, called the remainder, such that A equals B times C plus R. The remainder has to be greater than or equal to 0 and less than B. So for example, well, let's say we had 6 divided by 3. 6 divided by 3 is 2, with a 0 remainder. This is A, B, C, and R. So according to this property here, A equals B times C plus R. So 6 equals 3 times 2 plus 0. That's true. 7 divided by 3. This is A, this is B. This equals 2 plus 1. All right, so according to this is A, B, that's C, that's R. So we have 7 equals 3 times 2 plus 1. 3 times 2 is 6. 6 plus 1 is 7. And it's true. So that's the division algorithm. That's what we're going to try to live by. There has to be a unique number C for it. All right, let's look at how do I say this? Different ways to say division of two numbers. A and B. So we have A divided by B. We say that A is divisible by B. We say that different if the remainder equals 0. Because everything else we have remainder, hold another way of saying it. So if this one gives us a remainder of 0, then say A is divisible by B. B is a divisor of A. B divides A. There's another way you could say this also. B is a factor of A. Since we're talking about factors. Let's take an example. let's say if 1, 2, 3 is divided by a number, and the remainder is 13, what are the possible divisors? Remember, here it says B is divisor. So we're looking for what number goes on the bottom. So we have 123 divided by B. What numbers can we divide into there that give us a remainder of 0? So we use our formula. A equals B times C plus R. We know that R equals 113. A is 123. We don't know what B is. So we have 123 equals B times C plus R. We're trying to find this, what two numbers multiply together. Well, R is 13. It's defined there. So let's subtract 13 from both sides. 123 minus 13 is 110. So what we have to do is find what numbers multiplied together give us 110. So we have 1 times 110. 2 goes in 11 5 times with 1 left over. That's 110. 110. 3 doesn't go in there. 4 doesn't go in there. 5 times 22 goes in there. 6 doesn't go in there. 7, no, 8. 9. 10 times 11. 13, 15, no. 15 can't go in there because 5 and 3. There's no 3. So, okay, this is all we can go have. So the possible divisors, they have to be bigger than 13. Because if it was less than 13, then they wouldn't have remainder of 13. So our possible divisors are 110, 55, and 22. Those are our possible divisors because they're greater than 13. All right, let's look at this other one. Now we move on to another property. Division by 0 and 1. Division by 0 is pretty interesting. We have 3 possible conditions here. We can have 0 divided by a number divided by 0, or we can have 0 divided by 0. Remember, we have to use the properties that we had up originally. All right, so let's use numbers. Let's say 5. Let's say B is 5. Zero divided by 5 equals some number C. Remember from our earlier, that's what we have. That's what time, and because we want the remainder to be 0. So A divided by B equals C. If and only if five times C is equal to 0. The only way this could be true is only if C is equal to 0. Nothing else makes that true. So the answer to this, if 0 is on top, is 0. All right, let's look at the bottom, the next one. Is 0. So this one is A divided by 0 equals C if and only if 0 times C equals A. Remember, this is equal to C. 0 times, so 0 times A, 0 times C has to equal A. So for our example, let's say we had 5 on top. So what I'm saying here is 0 times C equals 5. So what's saying here is, can this ever happen? 0 times C. So no matter what C you have or you choose, it will never equal 5. Because 0 times anything is always 0, and it will not equal 5. So here, if you have 0 on the bottom, it's no solution or does not exist. Or you say it's undefined. All of them mean the same thing. DNE is does not exist. No solution. And undefined. Typically we say undefined or does not exist. Same thing with this one. So 0 divided by 0 equals C. So 0 divided by 0 equals C if and only if 0 times C equals 0. This is true for any C. So C is not unique. Remember, the definition says it had to be unique. Since C is not unique, then we have then it is undefined, DNE, no solution. So if the 0 is on the bottom, if you ever have a 0 on the bottom, it's undefined. Bottom line, if 0 is on the bottom, it's undefined. If 0 is on top, it's 0. Division by 1. From the unity property of multiplication, or identity, not unity, identity property of multiplication, we have any number times 1 equals itself. For any whole number A. So with that, A divided by 1 is also A. So that's the property. Anything divided by 1 is itself. Or another way to look at it is everything is divided by 1. In other words, if I had the number 6, 6 is the same thing as 6 divided by 1. All right, now relating multiplication and division as inverse operations. Inverses remove that operation, that number. When we say inverse operations, if I multiply, what do I multiply by A to get equal to 1? Since this is A over 1, the inverse is 1 over A. If I multiply these two, the A's cancel, I get 1. If I get an answer of 1, then those are inverses of each other. Similarly, A plus what gives me 0? Remember, we're trying to remove the number, get rid of that number. How do we get rid of A? We divide by it. How do we get rid of A here? We add the negative of it. So we say that A minus A equals 0. These are inverses. They remove that number. So multiplication and division are inverse operations. They cancel. We need to that's the only way we can cancel these numbers is if we multiply the multiplication by division. So that's what it says. Inverse operations. We have addition. We have subtraction. These are inverse of each other. We have multiplication and we have division. These are inverse of each other. So now how are addition and multiplication related? How are subtraction and division? Repeated addition gives us multiplication. Repeated subtraction gives us division. So those are inverse operations of each other. Addition, subtraction are the same level, multiplication, division, same level, but we can't go from division to addition. That doesn't work that way. Exponent properties are a property since only one. Using the definition of division. Remember exponents. Oh. So it's any number raised to a power. This power is the exponent. This number down here is the base. So the theorem states this. If A, M, and N are natural numbers. Okay, remember, natural numbers are 1, 2, 3, and so on and so forth. We cannot use 0 in there yet because we haven't defined that process. So if A, M, N are natural numbers, where M is larger than N, then if they have the same bases, A to the power M divided by A to the power N, as long as you have the same bases, you subtract the exponents. Because remember, division makes things smaller. Subtraction makes things smaller, so they have to go together. Or A to the power M over A to the power N equals A M over M minus N. Remember, the top number M is bigger. Here's a proof. Let's go ahead and prove this theorem. So let's look at A to the 5th divided by A to the 3rd. We have the same bases, they're both A's, M and N. And this number, 5, is bigger than 3, so M is bigger than N. What does A to the 5th mean? It means A times A times A times A times A, 5 A's, over A to the 3rd. Because we're dividing, we reduce 1. Whatever's the same on top and bottom, you cancel. We're left with A times A, which is A to the 2nd. According to our property, so we have 5 minus 3. So it works. So that's how it works. That's the division algorithm. Remember, in multiplication, of exponent. So we have A to the power M times A to the power N. Since we have the same base, we add the exponents. A to the power N, all that raised to the power N, you multiply the exponents. So those are reviews for those. All right. Let's look at some algorithms. Using base 10 blocks. All right, so how do we do this? Let's look at this number. So, for example, 726 divided by 6. We first have to create this number using blocks. So 726 breaks down into 7 100s, 2 10s, and 6 1s. So the 100s are those blocks. So 1, 2, 3, 4, 5, 6, 7. There's 700. 1, 2, 3, 4, 5. No, that's 600. 7. 20, those are 2 bars. The bars have 10 each. And then the 6, 1, 2, 3, 4, 5, 6. Remember, we divided, so we want them in groups of 6. So it's 1, 2, 3, 4, 5, 6. That equals 1 time. We get one group of 6. This one is 100. And these are 2 10s. So this, or these, I can break this up into 10 1s or 10 10s. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 more, 11, 12. Remember, I'm dividing by 6. So 1, 2, 3, 4, 5, 6. This is one group. 1, 2, 3, 4, 5, 6. This is 2 groups. So it goes in there 2 times, once, twice. So that takes care of all of these. All we have left now are 6 1s. I'm dividing by 6, so that goes in there 1 time. So 726 divided by 6 equals 121. We use the same concept in the standard form, or standard method. 726 divided by 6 is the same thing as 6 goes into 726. So 726 divided by 6 is the same as that. The same as that. Okay. So how many times does 6 go into 7? 1 time. 1 times 6 is 6. Subtract them. 7 minus 6 is 1. Bring down everything else. 6 doesn't go into 1. So 6 goes into 12 2 times. 2 times 6 is 12. Put a 0 there. Subtract them. Cancel, cancel. 6. 6 goes into 6 1 time. 1 times 6 is 6. The remainder, this is the remainder. Since the remainder is 0, that's our answer. That's our quotient. So that's using base 10. This is the standard blocks. You can also look at what are called partial quotients or scaffolded algorithm. Partial quotients. So let's look at 32 goes into 4224. From this first one, 32 goes into 42 one time. Okay. This is ones, tens, hundreds. So that's 100 I used. 100 times 32 is 3,200. Subtract them. It's 1024. $32. How many times does 32 go into 100 and actually, can we use any more hundreds? 3,200? No. So we have to use tens. 10 times 32 is 320. We're going to keep on making it smaller. 4, so we subtract them. 4 minus 0 is 0. 2 minus 2 is 0. 10 minus 3 is 7. Can we have 10 more of these? 10 times 32 is 320. 4, so we have to borrow 1 from here. 10 minus 2 is 8. 6 minus 3 is 3. Can 320 fit in there? So we have another 10. 8 minus 2 is 6, and those cancel. Okay, 32. So that goes in there one time. 32. Subtract. We get 32. And another time. We get 0 remainder. So looking at this, we have 1 100. We have 3 tens. And we have 2 ones. So 4224 divided by 32 is 132. Basically, all we're doing here is seeing how many times, how many hundreds of 32s fit in there. How many tens of 32 fit in there. How many ones of 32 fit in there. So that's the partial sum. All right, because I will also look at order of operations. Eight minus 9 divided by 3 times 2 plus 3. Using order operations, how do we simplify this equation? Are there any parentheses? Any special operations? No. Reading left to right, are there any multiplication divisions? That's a subtraction. Here's a division. I have to do that first. So 8. 9 divided by 3 is 3 times 2 plus 3. Are there any special operations? No. Any multiplication division? Here's a multiplication right here. So we have to do that next. 3 times 2 is 6. Special operations? No. Multiplication division? No. So addition subtractions, left to right. 8 minus 6 is 2 plus 3. No special operations, no multiplication division. So 2 plus 3 is 5. So there's your answer. Okay, let me see this one. Put parentheses around what you have to do first to get this side to equal that side. Right now, if you leave it the way it is, you do 3 times 2 is 6. 6 plus 4 is not 14. So what we have to do here, 3 plus 4 is 7. 7 times 2 is 14. So that's what we're doing these next couple ones. 9 divided by 3 plus 1 equals 4. Place parentheses, or what you have to do first. 9 divided by 3 is 3. 3 plus 1 is 4. So that equals. Five plus 4 divided by 9 divided by plus 9 divided by 3 equals 6. So the parentheses here I could put 2 sets of parentheses. 5 plus 4 is 9. 9 plus 9 is 18. 18 divided by 3 is 6. Three plus 6 minus 2 divided by 1. Same thing here. So we put further. So 3 plus 6 is 9. 9 minus 2 is 7. 7 divided by 1 is 7. That works. We can divide using mental math or estimate. So 47, I'll say 45 divided by 5. What we could do here is, since 5 is a whole number, let's round this one up to 50. 50 divided by 5 is 10. So we know since we rounded up, we went up, it's got to be less than 10. How much left? If we take away, we added 1, now we take away 1 from here, we know it's going to be 9. 27 divided by 3. Round it up to 30. 30 divided by 3 is 10. Since I went up 3 points, which is just one more of these, I subtract 1. So 27 divided by 3 is 9. Bases other than 10. Here we do the same thing we did with the subtraction aspect, but we'll do this next time. Okay, everybody. Have a great day. Then we're almost, let's see where we are. We're finished pretty much almost one more thing. So we're pretty much finished with chapter 3. We'll finish chapter 4 next week. Yeah, it was greatest common divisor, least common denominator. These all fit together. And divisibility, I have to give you a sheet for those. And we'll try to finish, we'll do 4.1 next time. And then next week we'll do 4.2 and 4.3. And that brings us to spring break, which is right here. And then as you can see, the second half of the semester, we got 2 in chapter 5, 3 in chapter 6. So we can finish those up pretty quick. And so we should be finished pretty early so we talk about the final project. Okay, everybody, have a great day. See you on Wednesday.